represents one of two positive numbers whose sum is 33. Part A represents the other number in terms of x. Any ideas? Okay. We said sum, which means you do what? So we know x plus this other number, if we call it y, equals 33. I'm asking you what y is equal to. So what would y be? So if they add up to 33, one number is x, the other one is 33 minus x. Part B. Find a function that represents the product of the numbers.
X times y equals 33.
Well, okay, so product is x times y, but do I know what the product equals to? No, so I'm just going to call this P for product. But more specifically, if I don't want two different variables, because we can't solve equations with x's and y's, what can I say my product is? I don't want y. What is y equal to?
33 minus.
So the first number is x. Part A, we found the other number was 33 minus x. Or if you distribute 33x minus x squared. Is this looking like one of the problems you might have done yesterday? That basketball court one? All right. So part C. I want the numbers that would give me the maximum product. So if I want to make my product as large as possible, what would my numbers have to be? So if we take a second look, 33x minus x squared, if you graphed that, what would it look like?
Upside down parabola.
Okay, it's an upside down parabola. So if I want the maximum for a parabola, what do we have to do? Find the vertex. How do we find the vertex? So the x value is the opposite of b, so negative 33 over 2 times a, which is negative 1. 33 over 2 is 16.5. Did I ever say that it couldn't be a decimal? No. So then, if I want the product, what would we do? Plug that in for x. My product is x, so 16.5 times 33 minus x. So the numbers are 16.5 and 16.5 is the first number. How do we get the second number? Plug it in where? The y is 33 minus x, so 33 minus 16.5 is 16.5. The maximum product is 272.25. Any questions on that one? Try another. A piece of property shaped as a right triangle. So what should I probably do? Make a right triangle. With the longer leg 10 meters shorter than twice the other. Okay, the legs are the sides that touch the right angle. So let's start with the shorter one. Did I tell you how long it was? So what would I call that? X. The longer one is 10 shorter than. So what does that mean? Twice the other. 2x minus 10. The hypotenuse is 20 meters longer than the longer leg. What does that mean? Okay, the longer leg, 2x minus 10, longer than, so plus 20. Or you could simplify that to 2x plus 10. So if I want the lengths of my legs, if I have a right triangle, what can we do? Pythagorean theorem. Because I didn't tell you perimeter or area or anything like that. But we know that in a right triangle, Pythagorean theorem works. So I would have x squared plus 2x minus 10 squared equals 2x plus 10 squared. Remember, it just has to be the hypotenuse is c. A and b could be either one. So we have x squared. How do you do 2x minus 10 squared? FOIL it. So that would be 4x squared minus 20x and minus 20x is minus 40x plus 100. Over here, if we FOIL, we get 4x squared plus 20x and plus 20x plus 40x plus 100. We always set quadratics equal to 0. So x squared minus 80x equals 0. Then what would we do?
Factor out an x.
So x equals,
0
we can set each of those equal to 0. So we get 0 and 80. Okay. The question was, to find the lengths of the legs. Can x be 0 in this? No, we can't draw a triangle with a leg of 0. So we can throw that answer out. So the legs are, we could have 80 and we were in meters. The other leg, 2 times 80 minus 10, will be 150 meters. don't you guys, let's go ahead and take a second, read this, see if you can set up a picture. So a farmer wishes to enclose a rectangular region. So everybody drew a rectangle. He has 120 feet of fencing and plans to use the barn as one side of the enclosure. So that means we're not actually putting fence over here. That's where the barn is. Okay, so I'm only actually building a fence around 3 sides. What would the 120 represent? Right. All right, so we need to label these with something because I didn't tell you what each side length is. So if I called this one X, we know in a rectangle opposite sides are the same. What would I have to call this one? Something else. So if I called it Y. So if I add all 3 of those together, it equals 120 because we have 120 feet of fence. Can we solve problems with both X's and Y's? No. So let's figure out what Y is here. So Y would be 120 minus 2X. So instead of calling this side Y, I'm going to call it 120 minus 2X. It's kind of like that basketball court problem again, isn't it? How do we get the area?
X times 120 minus 2x is.
So there's my equation for area. Part B, we want the maximum area. So what am I asking you to find?
Vertex.
Vertex. How do we find it? What do I do with that?
Plug it into 120x minus 2x squared.
Okay, if you want to find Y. Oops, sorry. You want to find area. Plug it into our area equation. And we get so, my maximum area would be 1,800, let's see, our dimensions were in feet, so square feet. Area is always squared. What dimension should be used? When I ask for the dimensions, what am I asking for? Mm-hmm. So if my X is 30, and how did you get that? You can plug it into your Y equation, or you can do the area divided by 30, a couple ways of getting that. questions? Do we need more practice with these problems? Okay. So what I have now is there's a handout posted on Google Classroom. You are welcome to work with your same partner that you've been working with on your project. So that's your homework, and that will kind of wrap up this chapter. So tomorrow we'll start reviewing all of chapter 3.